Example 3 introduces some interesting wording, and that's the key thing we have to pay attention to in this question. The question says, for which values of the variable is each radical defined? So this language starts to come up now in grade 11 and in grade 12. They're basically asking, where is it possible? What domain or what x values make it possible? Well, for square roots, we know that we can't take the square roots of negative numbers. But when looking at this, will the number inside ever be negative? Could you plug in an x value that would make the number inside be negative? What would happen if I plugged in -1? What's -1 squared? +1 times 27 would be +27. So -1 is okay, because I wouldn't take the square root of a negative. Are there going to be any numbers that make the inside negative? So that's what we have to think about. Are there any numbers that are not possible? So in this case, if you plug in 5, it's positive inside. If I plug in 10, it's positive. If I plug in -3, -3 squared would be +9. It would still be positive. Can you see that no matter what number you think of in this case, the inside will always be positive? So when we talk about the domain where this one is defined, it works for everything, and we would say that x could be anything for this one. Every number works for A, because no matter what number I plug in, the inside will be positive, and the only thing you can't do with square roots is take the square root of a negative. For B, the index is even again. So anytime we have an even index, we can't take the square root, the 4th root, the 6th root of any negative number. Can you tell me a number that you plug in that would be bad? Let's just start making a list of numbers that don't work. What can't we plug in? X can't equal what number? Or even better, Tatum, tell me a number, we'll check if it works or not. 3. So let's try 3. If we plug in 3, 3 times 3 times 3 is 27. 27 times a -12, will that be a positive or a negative number? It'll be negative. So 3 won't work. X can't equal 3. Or you don't have to write this down. We're just making a list of numbers that either work or don't work. Can you tell me another number that doesn't work? 7. If you plug in 7, 7 cubed is a very big number, times by a -12 will still be negative. 7 would be bad. Can you tell me a number that you could plug in that would work? Sorry? 2? Well, 2 times 2 times 2 is 8. 8 times a negative, still a negative number. Can't be 2. -2 works. Because -2 times -2 times -2 is -8. And -8 times -12 is a positive number. So -2 works. What about another negative number? Will it work? So it seems to be so far that we've decided that negative numbers work and positive ones don't. What about 0? What happens if you plug in 0? 0. And what's the 4th root of 0? 0. So 0 works. So we just, through thinking about some numbers, we have found out that positive numbers don't work. Negative numbers work. and 0 works. And this is often a very good strategy for thinking about the domain or where a radical is defined. Think about positive numbers, think about negative numbers, think about 0. So how do I write this as a domain? If I want to write all the negative numbers and include 0, does that make sense? That x has to be less than or equal to 0. Okay? For the first one, we could have done the same sort of strategy. Positive numbers, they're okay. Negative numbers, they're okay. 0 is okay. Everything's okay. And that's why the answer was everything. Homework for 3 is number 6. We're going to go on to number 4 right away.